Welcome to lecture 1 of Newton's laws, and you notice at the top of the page here's the website that you can get the notes for this section. It's just http://db.tt/Y lowercase I lowercase m lowercase g 8 lowercase u 6 lowercase g. Today we're going to look at two equations, F equals ma and W equals mg. F is force, m is mass, a is acceleration. You can see that the acceleration is still the same units as it was in kinematics. Mass is your new one and force is your new one. Mass is in kilograms, force is in newtons. You're probably wondering why we're doing W is equal to mg. Well, it's the same as this. As you remember, the definition of weight is a force. So we can notice weight, newtons. M is mass, okay, and G is gravity. Normally, when we think of weight, we'll be talking in the vertical direction, and F equals ma is in the horizontal. In some textbooks you might see a net here, but we're going to forego that one in this lecture. So let's look at the first one. It says, what is the force? And remember, if you label these, it'd be a lot easier to figure out which equation you're dealing with. So what is the force needed to accelerate a 20 kilogram, okay, there's a mass, and 2.5 meters per second squared. So there's A. So F equals ma. So F equals, okay, be 20 times 2.5, and F, and like I said, I am not going to do the calculation. We're doing the setup and the units for the answer. So force will, in our purposes, will be in newtons. Here's another one. Okay, I've got a 26,000 Newton force that's used to accelerate an object at this acceleration rate, and it says what is the mass. So F equals ma, so this is 26,000. Since newtons is a unit of force, I need the mass. I know my acceleration is the 4.7, and mass is in kilograms. And we're going to just kind of skip around because these are pretty much straightforward. Let's look at this one right here. It says, what is the mass, okay, I got mass, of a 150,000 Newton object? So there's a force. Well, you're probably thinking, I don't have all of my numbers here, but remember, I'm not accelerated, so so I can equate this to weight. So W equals mg. So I'll just quick plug in here. There's 150. Now I want to know the mass. Now we're going to use 10. Your instructor might have you use 9.8, but 10 is okay for our purposes. And you know this is just still masses in kilograms. Another one that could be given to you, it says, what is the normal force? Well, if you remember your free body diagrams, a normal force is on a surface. So normal force is up. What's going down? Weight. So there's your weight acting on a 40 kilogram object. So we know that W equals mg. So we're looking for the normal force or the weight. That's 45 times 10. So the weight will be in newtons. Another type of problem that your instructor can give you is what is tension? Now tension, as you know, is a force, and if you're hanging, remember, okay, this is tension, what's going down? Weight. So weight, which is tension, mg. I'm not going to fill it out, the rest. You can see this one over here is the same way. Here's one. Now, we have a mass here and a weight. Okay, now don't assume that if you have W that it's always going to be 10, because I didn't say this was on Earth. It's on a distant planet, so I'm still looking for this. And 650, and I'm looking, my mass is 300, and I'm actually looking for G on this planet, and we know that G is in meters per second squared. And here's another one. I'm probably doing more than I did more in this than I've done the others, but these are quick and painless to do. I have a helicopter hovering. Okay, it says hovering, so it's not moving one way. So how much force is to keep it hovering? And remember, this is our little perfect little physics world, as I tell my students. As we know, in real life it's going to be greater, but it's got to at least support its weight for it to stay in one spot. In other words, we're not losing any downward force. And you're probably thinking about that 100. Disregard, because we're not moving it, and so it is not affected in the problem. This is the 10 for the gravitational acceleration. And that's pretty much how you do an F equals ma or W equals mg equation. They're quick, painless, easy points. Remember, if you have any questions, don't hesitate to contact me.